Last year, I was putting together the conference for the first time, and I was asking my network, if you were having a conference about the future of supply chain, who would you invite? And Carol Hom from Logitech said, oh, you just have to know Phil Depallens. He's doing some wonderful things around additive manufacturing. He's really driven a whole change transformation in our organization. And I'm like, great, I'm going to call him. And he politely said, I'd love to come and do your conference, but it's got to be next year. So I've been waiting 2 years for him to do this talk, and he's going to do a great job. So please welcome him to the stage. Thank you very much.
Good morning, and thank you, Carol, and I'm sorry to have made you be patient for about a year. So Imagine was where we about a year and a half ago, about 18 months ago, when we were working on our current products, and we were thinking about how are we going to be able to reinvent ourselves? How are we going to be able to scale our current production? How are we going to be able to, more importantly, serve our customers? But before I go there, I would like to give you a little bit of a context, and I'm going to tell you a little story. Does anybody in the audience know what is the biggest problem that musicians suffer of? I see some nodding here, so what is the biggest problem? That's right. That is correct. One of the biggest problems that musicians have is to actually hear themselves as they are performing on stage. And the reason for that is when a musician goes on stage, they rarely have the right equipment to play back so they can hear themselves. What they have is speakers that are around the stage that are called monitors, and those monitors play back what they are singing or what they are playing, and also the rest of the band. Unfortunately, the majority of the time, those speakers are competing against each other, and the musician can't hear themselves. So what do? Naturally, they turn towards the sound engineer and say, put it louder. By putting it louder, now the next musician is not able to hear himself. They play this game, and now everybody still can't hear themselves, but now they have loud music blasting into their ears for too long, and unfortunately, they suffer of massive hearing losses. So I'm going to take you back in time, in 1995, and I'm going to take you on a backstage of a very famous rock band. And that famous rock band had a drummer, and that drummer had been drumming for a long, long time, and unfortunately, he was suffering a very, very big ear losses. He was suffering from a disease called tinnitus, which is your ear constantly whistling. So at this point, he goes to his sound engineer. He says, you've got to do something for me. You have to help me. You have to find a solution for me because I can't continue this way. So that sound engineer, and our company was founded not in a garage in Silicon Valley, but in the back of a tour bus. And our company was founded by a guy that tinkered with hearing aid components and put together a device that would actually fit inside the ear of the musician and replace that monitor. This is why our products are called in-ear monitors. They are essentially monitors that are on the stage that have been brought inside your ear. So our product is essentially a very, very high-end earphone that has been custom fitted to fit perfectly inside your ear. So I'm going to pass around a couple of them so you guys can actually experience them. So don't have the temptation of stealing them because unfortunately they are designed to fit only somebody's ear and nobody else can be able to wear them. So here's a couple so you can pass them around. So the product is made of an acrylic, and that acrylic is then populated with up to 6 speakers per ear. So the reason why we put so many speakers in there is because as a musician, as you want to really perform at your top, you need to hear yourself clearly. You want to be able to hear your voice perfectly. You want to be able to hear the guitar, all the other instruments. So our products are made of this acrylic and then populated with the different speaker and then closed, so it's a closed cavity. So before I tell you about our reinvention, I usually, at this point, when people come to my office, give a tour of our factory. Our factory is based in Irvine, California, about 60 miles south of Los Angeles, which is a great location for us because it allows us to be very close to most of the musicians that are either rehearsing or performing in Los Angeles. The process for us always starts by having a customer going through what we call taking an ear impression. So what does that mean? It means that we have a network of certified people around the world that we call audiologists that will actually insert inside your ear a little paste, a little silicone-based paste that's going to dry in about 5 minutes and will give us the exact shape of your ear. That process is extremely important because every ear in this room is actually different, and there is no way for us to guess what your ear looks like if we don't get a perfect impression. So this is why we're using people that have been certified, but this is why we also have very specific specification on what we need in order to get that ear. And in this process, we always ask the audiologist to take more of that impression so we don't have to guess what your ear looks like. So the first step, once we receive that ear impression into our office, we do what we call the detailing of the ear impression. The detailing means by hand, one of our factory workers will remove all the excess material until it gets to just what we need. The next step is the making of that acrylic shell that you saw in the previous slide. So the way we do this, we take that detailed ear impression, we create a cast. From that cast, we pour a liquid acrylic, all by hand, as you can tell. That cast is then put into a UV curing oven. That UV curing oven will harden the shell, and depending on the color, it stays in that oven for a couple minutes or just a few seconds. We extract that shell out of the cast, and we just remove all the excess material. Now that shell is ready to be populated with all the speakers and the electronics that will make that earphone function properly. Last stage, after the speakers have been put inside the device, we actually fine-tune and optimize the sound signature to the specification that we have based on the shape of your ear. So that earphone will play a pristine sound exactly matching the spec that we have based on the shape of your ear. Once this is ready, we add the faceplate on the outside. We seal it completely, so when you wear the device inside your ear, if you happen to sweat, if anything would come from the outside, nothing will actually affect the component inside. And then, and finally, we offer the customer the ability to bling it up. So what does that mean? It means that you can completely personalize the product up to your liking. So you can see that the sky is the limit here. You will see at the bottom left here, for instance, it's actually a Japanese maple tree that was made with little electrical wire by hand, and then a bunch of little rhinestone were added to make the flowers. Okay? So as you can tell, it's a very labor-intensive, and a lot of the work that we have to do cannot necessarily be made automatic because every ear is different. Last final steps, we package the product. We laser engrave a roadie box, something that you can carry on the road and will protect the product. We laser engrave it with whatever name you want on it. And then we ship it. And final stage, we take that ear impression and store it into our warehouse that you can see here. So for the last 19 years, we have actually had more than 50,000 ear impressions that have been stored in this warehouse. So the principle that we apply, the DNA that we have applied for the last 5-6 years in our company is to really focus on the customer and constantly learning from that customer and look at it not just as a product. For us, the product is not just what we produce, but it's the journey that we have with that customer. And we have an opportunity to delight that customer at every single touch point. And the best way for us to continuously improve, continuously make a better product is to interact with that customer so our future customer will benefit from that. We are so driven by this, we're so obsessed by it, that if you were to come to my office, you would actually see this display. And this display is the customer journey separated in about 8 different steps. And in front of it, you can see all the improvements that we've made over the years. Because the goal for us is that every single touch point within the company, you have an opportunity to make an improvement, and you have an opportunity to make that customer more delighted. Unfortunately, when you're doing this concept of continuous process improvement, you can run the risk of continuously improving something that could become obsolete. Right? If you think a company like Kodak several years ago, they probably were the best at printing pictures on pieces of paper, but unfortunately, slowly but surely the industry went somewhere else, and they were the best at something that was completely useless. So about 18 months ago, we started to challenge ourselves and saying, what if it happened to us? How can we reinvent ourselves and avoid that type of issue? Our objective was to continue to leverage the artisan handcrafted techniques that we have, the great knowledge that most of the team that we have in our organization has acquired over the last 15 years, but we also wanted to leverage some of the new technologies that exist currently on the market. So if you think about that process of taking an ear impression, let's just take the example that you are in Germany or you're in Japan, and you will want to order a product from us. So what you're going to have to do, you have to go to an audiologist somewhere around the world. You're going to go to that office. That person will take that ear impression, and then you're going to have to put it into a box and use a standard snail mail to ship it to us in California. So just that process will take 5 to 7 days to get to us. Oops, I'm sorry. So if you think about the instant gratification, I want it now, 5 to 7 days is very, very far away from that. So that's when we started to challenge ourselves and say, how can we reinvent ourselves and eliminate that 5 to 7 days? How could we use new technologies to get there? That's when we started to look at the concept of 3D scanners. We have a 3D impression. We absolutely need the very high precision of that impression. However, if we were able to digitize that impression and put it into a computer, we would have the ability to bypass the snail mail and be able to send an email or put it on Google Drive and receive that impression. So we looked around and we finally found some scanners that were used in the hearing aid industry that we could leverage. And so now we were able to take an ear impression and bring it into a computer and ship it to us in Irvine without having to use the regular mail. So we went from 5 to 7 days to maybe a few minutes. So that was fantastic. That was really cool that we had that ear impression now into a computer. But now how do we go from that ear impression back to an acrylic shell? So we looked around different softwares, and we found this CAD software that would allow us to do the exact same detailing process that we used by hand as we were removing all the different components, but we could do it in the software. So the gentleman that you see here was actually the person that was doing the detailing by hand that has actually learned over time on how to do this in the computer. And here we were at a sort of a fork in the road because we could have hired some CAD expert and teach them on how to actually detail your impression, or, which is what we did, we actually taught the people that were doing this ear impression and understood exactly the physiognomy of the ear and understand what you have to do to get a good detailing impression and train them on a new computer. So initially, they went from making dozens a day to maybe one a day, right? Because it took a long, long time to actually learn that process. But over time, we started to realize some great benefits, and I'll get into that a little bit later. So now we have scanned that ear impression. We have detailed that ear impression. And the beauty of doing it in the computer is there is a really magic function in the software. It's that undo function, right? So when you are doing something by hand and you break it or you remove too much material, it's impossible to undo. With the CAD software, we had the ability to detail the ear impression. If it wasn't working well enough, we could undo and go back to the original shape. We could also constantly, as we're detailing the ear impression, see the before and after and optimize the way that detailing would be. So the last element now that we needed to do is to go from that ear impression that has been detailed back into physical acrylic. So again, here we looked around at different technologies, different tools. Oops, sorry, it's going too fast there. And what we've discovered is that if we put all this different detailed ear impression into a virtual tray, we could ultimately send that virtual tray to a 3D printer. So what you're seeing here is the 3D printer that we have in our office in California. And this is a super high resolution 3D printer. Your ear is extremely sensitive. And so if we were to print a shell that would be too big, very rapidly that shell would actually would hurt your ear. So we found this, and when it was delivered, it took 3 days to be set up properly into our factory. And we started to play with it. And of course, it's kind of like if you receive Photoshop, people deliver to you Photoshop, and they will tell you on how to really work with it, right? So you need to learn how to use the equipment. And when we started to ask different questions, we said, look, the impression when it gets printed is all murky. It's all, the guy said, look, I don't know anything about this. That's going to be something that you're going to have to find out. And so when we started to ask questions around, that was sort of the secret sauce that most of the people that were using this machine were developing on their own. So we had to do the same thing. We went through the same process. So if you think about it from a supply chain standpoint, we took a little bit of a step back because we became a little bit less efficient, but we believed in the vision that we had there, and we started to dig into it and understood better and better what it would take. And so over time, and it took a little while, we started to be able to print shell into that 3D printer. So it's an additive process, and it takes about an hour and a half to print this shell. So you imagine this vat in the bottom that has that acrylic, and imagine a laser that will actually print one layer, and the vat's going to go down a little bit, and it's going to be another layer until the entire ear is actually printed. So then we can take that ear out, that raw ear out of the printer. We can detail that ear and UV cure it to make sure that everything is perfect. And we ended up, after several months of working, to a perfect ear impression that would look actually better than the one we used to do. Okay? So we went through this journey. It took a long, long time to get there. And one of the key things that we wanted to do is to make sure that we actually had created a better experience for the customer, but also more importantly, created a better product. So what we decided to do is to not tell anybody about the fact that we're printing these devices in 3D. What we decided to do is to slowly insert this new process into our standard way of creating products and ship it to different customers. Because as you probably know, if you go to a great restaurant and you tell your friend the food's going to be excellent, unfortunately your mind is a little bit polarized, and you will start to say that food is excellent. So in this case, we told nobody to make sure that there would be no tinted answers to our questions. So we let it run for a year. And today is actually the first time we're actually going public with the fact that we're printing things in 3D. Next week, we'll have some article in the press that will be actually going out. And what was really, really interesting to us is after one year, we have been able to improve our overall cycle time. We have now several of those scanners at different locations in the world. The more important one is in Germany, where our partner in Germany is actually sending to us on a daily basis ear impression that has been scanned in 3D. So we have eliminated all that time that it takes to take ear impression and to ship it to us. The second one, and this is the best for me, is we have significantly improved the quality of the product. And the way we measure this is as we shipped about 3,000 of those ear one way, 3,000 the other way, we looked at all the returns and all the customers that were not satisfied with the product, and we started to tabulate the difference. And we saw 50%, actually more than 50% reduction for the product that were 3D printed versus the product that were not 3D printed. Okay? Huge advantage for us. Now we have a new technology that allows us to scale, but on top of that, it delivered a much, much better product. Last but not least, it also eliminated all the potential deterioration that you could have as you're storing those ear impressions, as you saw, into a warehouse. Because now instead of storing a physical ear impression, we just store a digital ear impression. It also gave us a great opportunity to actually be able to satisfy a customer that want to reorder something, because if you reorder, we just press print, and we have exactly the same product that is printed a second time. But the number one benefit that we got out of all this reinvention for us, we actually delivered a much, much better product and a much, much better experience. And I think the biggest story that I have here is what was a big revolution for us is that by working together as a team, the product designing team, the supply chain, the engineers, and really having everybody at the table and painting a single picture, and that picture was, we will deliver a better product and a better experience to our customers, made a world of difference, because now everybody saw the value that they had in the entire chain to actually deliver a better product. And so the best learning for me is that the innovation don't always happen in engineering. The innovation don't happen necessarily in sales and other places. The supply chain, especially in our business, had a huge opportunity to actually make a better product. Thank you.
When you were imagining your future, how did you get the management team on board? How did you help them with new mental models? Was it easy? Was it tough?
By definition, change is scary. By definition, change is something that people will resist. And so I think the biggest lesson that we've learned through the process is if you put a goal which is not an internal goal, but the goal is to satisfy the customer, and where the customer is the final judge, it helps for people to actually embrace what you're going to be doing. Because instead of having a contest of who is right, who's wrong, the ultimate judge out there is the customer, and the way you validate that you have done the right thing is customer buying your product, right? So it is sometimes easy to fall in love with technology. It's sometimes easy to fall in love with some of the old stuff that you've done forever. But ultimately, what's going to make sure that you are actually doing the right thing is that the customer is buying your product. And so that's sort of how we infiltrated back to sort of the change management that we put there, is always putting the customer first and always bringing that to the table.
I think that's great wisdom. Any questions we got a question here. Manny, you told me last night you've been doing additive manufacturing for a long time in semiconductor, right?
What I was telling Laura, this is Manny, is if you look at semiconductor, it is technically an additive manufacturing. They're adding and removing layers. So we've been doing it for the last 50 years or something. But the question today primarily is a great presentation. As a 3D printing aspirant, what are the challenges we're going to be looking at? Is the challenge in deciding what works, what kind of design and product works for 3D printing, or converting a physical product into a CAD design, because the complexity of how we do that, or the post-processing? So the biggest challenge that we had in our case, because the product is actually worn deep inside your ear, was to find a process that would end up creating a product out of a material that would be compatible with your skin, right? So the biggest challenge that we had to resolve was to find a 3D printer that would be able to use the acrylic that we had that would print that product in 3D. The second challenge was, as you are scanning, as you're detailing, and as you're printing, are you able to consistently produce a great product, right? Because you could be lucky, and once you do it right, this next time. And so it took us a little while to really measure our ability to produce something on a daily basis that would actually satisfy the customer. And it took us a while there. It took us a while to learn. But the beauty of the software, and this is one of the key learning as well, is that when you are in the world of digital, you can constantly go back and forth between source and destination, and you can constantly compare. And we actually learn on how to make better things, because we no longer were at the mercy of a person working all day with this thing in their hand. And you can imagine it might be great and productive in the morning at 8 o'clock, but 3 o'clock in the afternoon, they may no longer as productive and may no longer as be careful. With the software, we had the ability to also have that consistency.
That's a great answer. Other questions? So where do you see additive manufacturing going? I mean, are you going to do other things with it, or got any Other plans?
So I believe the beauty of the additive manufacturing, it opens up doors of things that we were not able to do in the past, because in the past we were forced to be in one location. So now you can start to see it, like for instance the scanning is a great example, right? You can imagine having that 3D scanner. Initially it started in our office, but then we started to distribute those scanners across the world and optimize the supply chain that way. So I think it really opening some doors. We have some visions of where we want to go next, and now those visions are more likely to happen because now we have the basic foundational work that is in place, and so we can expand there.
Great presentation. Thanks for your patience.
Thank you very much.
And,
Thank you.
it took me 2 years because he didn't want anybody to know that he was doing this process, but I love how he's detailed it for the customer, right? And I think it should be all about the customer.